So number 40 says we got an object traveling in a straight line. It has a position of x of t at t equal or at any time t. And then it says if the initial position is 2 when t equals 0, and we're given its velocity, we want to find its position. So the integral of velocity, means the integral of v of t dt, is displacement. And that's exactly what we do, is displacement when we're looking for position. And so we just have to take our initial condition, which is that at t equals 0, it's at 2, and then add that to the displacement from 0, the time that it's at a position of 2, to 3, the time that we're interested in, of our function. And your graphing calculator will do the evaluation for that for you. It'll integrate the 0 to 3 of root or cube root of 1 plus 2 squared dt, and then add 2 to it. And my guess is the answer is probably choice D, but I could be wrong. That's just me guessing. That also might just be their trap answer. I don't have my graphing calculator in front of me because I opened up my graphing calculators, 3 of them, and the batteries that had been in them corroded. And so now all 3 of my graphing calculators are toast. Fun times. So what's, anybody got the integral from, I guess I can do it here. I'll do it on Desmos on my phone. But that's the setup. So the integral from 0 to 3 of the cube root of 1 plus t squared dt is 4.512. And if you add the 2 to that, you get 6.512.
If it asks for total distance traveled, would you ignore the 2 and then put absolute value?
Correct. Yep. Yeah, the total distance traveled doesn't care what the initial position was, so you don't need to add that 2 in, and it's always absolute value of velocity. That is correct. All right. Next one somebody was asking about was 43. So let's take a look at that one. So we've got a function that is continuous and twice differentiable. And we know that f prime of 3 is 2, f double prime is less than 0. And we want to know which of the following could be a table of values. So first off, if f prime of 3 is 2, that tells us that the derivative of f at 3 is exactly 2, which means that the slope of f is 2. And then here, if f double prime is less than 0, that means that the function is concave down. And if a function is concave down, what does that tell you about the slopes? They are always, if the function is always concave down on this interval, the slope should always be decreasing. Does that make sense to everybody? Right? The slopes are large positives and they get smaller positives and 0, then small negatives, larger negatives, and so on. Does that make sense to everyone? Okay. So that means that if we were to look at the slope between 2 and 3, it should be less than 2. And if we were to look at the slope between 3 and 4, it should be greater than 2 for whichever one is the right answer choice. So if we look at the slope between 2 and 3, it is, should be 2.5. Right, so it's not this one because that's not less than 2. If you look at this one, that slope is 2.5 again, so not this one. If you look at this one, that slope is 2. It's not that one. If you look at this one, the slope is 2, so not that one. If you look at this one, the slope is 1.5. So this is the only one it could possibly be. If we're going to have to, I said decreasing, which means I wrote those backwards. Good job by me. It should be greater than 2 and then less than 2. I'm sorry, I've screwed that up already. So this is greater than 2, this is greater than 2, this is 2, this is 2, and this is less than 2, so it can't be that one. Right, slopes are decreasing, right? So it's got to be larger than 2 when we're less than 3. It's got to be less than 2 when we are greater than 3. And so then we look here, this one, the slope between 3 and 4 is 1.5. This one, the slope between 3 and 4 is 2. So this is 2.5 and then 2. This one is 2.5 and then 1.5. The only one where it would always be decreasing would be here, because at 3 it's supposed to be 2. So if at 3 it's 2, and between 3 and 4 it's also 2, that could not work out. So we can't have choice B, it's got to be choice A. Does that make sense? Any questions there on 43? All right. Let's look at 16 next. Maybe. So here is 16. We are looking for dy dx of sine xy equals x. So we'll have to do that implicitly. So the derivative of sine xy, that's sine of u with u equal to xy. So it should become cosine of u times the derivative of u, so the derivative of xy, which you have to use the product rule for. So x derivative of y plus y times derivative of x, which is just 1, and then equals 1 on the other side. And then it looks like we've got, we can divide by the cosine of x, y, subtract y, and then divide everything by x. And that's not an answer choice, but in order to get the common denominator of cosine xy times that x, we'll just put a cosine of xy down here and a cosine of xy up here. So we have 1 minus y cosine xy over x cosine xy, which looks like choice D. Everybody okay with 16 there? Does that make sense? All right. Next one somebody was asking about was 18. So 18, we got the line x plus y equals k. K is a constant, and this line is tangent to the graph of y equals x squared plus 3x plus 1. We want to find the value of k. So this line is y equals negative x plus k. If we were to write it into slope-intercept form. And it's tangent to this graph here. And so this function should have a derivative y prime that is equal to 2x plus 3. And we know that this is the slope of the tangent line. If this is the tangent line, the slope is -1. So 2x plus 3 needs to equal -1. 2x is -4, x is -2. And if x is -2, we should be able to figure out what y value corresponds to that. So y ought to be -2 squared minus 6 plus 1. So 4 minus 6 is -2 plus 1 is -1. So the point is -2, -1. And that tells us that -2 minus 1 equals k, or k equals -3. Any questions there on 18?
Wait, where'd you get the 2x plus 3 equals -1?
So this is the equation, right? It's the slope of its tangent line should be its derivative, which is 2x plus 3. And this is the tangent line, and its slope is -1. So the slope of the tangent line, -1, needs to equal the slope of the tangent line, 2x plus 3.
Okay, thank you.
Any other questions there on 18? All right, 22 is the next one. That's not what I meant to do. All right, there we go, 22. A rumor spreads among a population of n people. Oh my goodness. At a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. So n is the total people. P is the number that have heard the rumor. Okay. And we want to find the right differential equation to model this situation. So it should be dp dt is equal to, and then it's going to, it's proportional to, so that means we're going to have this constant of proportionality, that's our k. So it's proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. So the number of people that have heard the rumor is P, and the number of people that have not heard the rumor is the total number of people minus the number that have heard it. So it's proportional to the product of P and N minus P. So dP dt equals K, P times N minus P. Looks like choice B. Does that make sense or no?
Can you explain that one more time?
Yeah, so we've got, it's the fact that it's proportional tells us that we have to have this K. And it says it's proportional to the product of the number of people who heard the rumor and the number of people who have not heard the rumor. Well, so if it's the product of those things, it should be P, the number that have heard, and N minus P ought to be the number that have not heard, because it's the total number of people in the population, N minus the number that have heard it. Does that make sense or no?
Yeah.
Okay. Anybody else? Any other questions on 22 there? All right. And then somebody was also asking about number 6. So Number 6, we've got which of the following statements about the function f are true? And we are looking at whether it's continuous, differentiable, or has a limit at x equals 2. So first off, number 1 here, does it have a limit at x equals 2? Well, we should be able to figure that out pretty easily. Just look for the limit as x approaches 2 of f of x. And as we approach 2, it's not this value of 1. It's the x squared minus 4 over x minus 2. So that's the limit as x approaches 2 of x squared minus 4 over x minus 2, which is 0 over 0. So you can either factor and cancel, or you can use L'Hopital's rule. Doesn't really matter. And you end up with 4. So does it have a limit at x equals 2? Yes. So anything that doesn't include number 1, we can get rid of. So it's either A, D, or E. Then is it continuous at x equals 2? Well, it's only continuous at x equals 2 if the limit of 4 equals the value of the function at x equals 2. Well, 4 does not equal 1. So no. And if a function is not continuous at x equals 2, I mean, this tells us the answer anyway, because 1 and 2 or 1, 2, and 3, well, it's only just 1. But if a function is not continuous at a point, it can't be differentiable at a point. And so 3 is also not true. Any questions there on number 6?
Can you just restate why it wasn't differentiable?
Yeah, if it's not continuous at x equals 2. So if a function is not continuous at a point, it cannot be differentiable at that point, no matter what. Does that make sense or no?
Yeah.
Cool. Any other questions from that?